Welcome everyone. In this video, I will talk about multiple choice questions related to matrix. In case if you are new to the channel, you should subscribe the channel because here I am uploading good quality video content related to mathematics. So let us look at the first problem. If A is a 4 cross 4 matrix whose eigenvalues are this, then what is the value of determinant of adjoint of A? To solve this question, we are going to use two concepts. So the first concept is, and you should remember this because this may help you in solving other questions as well. So the first concept is that what is the value of determinant of adjoint of A, and this is given by determinant of A to the power n minus 1, where n is the order of the matrix A, where n is the order of the matrix A. Okay. Second concept that we are going to use, that determinant of a matrix A is equal to the product of its eigenvalues. So in the first problem itself, we learnt two new concepts. So determinant of A is product of its eigenvalues. So first of all, if I have to calculate the determinant of A, I am going to take the product of these eigenvalues, that is 1, minus 1, 2 and minus 2. So this will be equal to plus 4, minus will become plus. And then we have to calculate determinant of adjoint of A. So this is 4 to the power n minus 1. So the n is the order of the matrix, that is 4. So 4 to the power 4 minus 1, that is 4 to the power 3. So 4 to the power 3 is 4 into 4 into 4. So 16 into 4 is 64. So the correct answer is B. So this is a good quality question because here we have used these two concepts and this can be separately asked also. So keep this in mind. Let us move to the next question. In this question, they are asking me that how to find the value of adjoint of A. And this is also a memory based question. So to answer this, you have to remember that adjoint of A is given by determinant of A to the power n minus 2 into A, where n is the order of the matrix, where n is the order or size of the matrix, Okay, gentlemen and ladies also. So what is the determinant of A? Determinant of A is 3, which is given. It is a non-singular matrix whose determinant value of A is equal to 3. And what is n here? N is 3 because this is a 3 cross 3 matrix. So n is equal to 3. So what will be the answer? Determinant of A is 3 and 3 to the power 3 minus 2 into A. So it is actually 3A. So what is the correct answer here? The correct answer here is A. Okay. Let us move to the next question. So this is a very popular question and this is repeatedly asked in different kind of exam. So they are asking what is the value of K for which the system of equation this and this have a non-trivial solution. So first point you need to notice here that this is a homogeneous system of equation because we have zeros in the right hand side. And for a homogeneous system of equation, what is the requirement? So let me write the concept for first, because the problem, see, when we are solving the problem, it should not be seen as that this is the only problem that I am solving. I am solving many problems through this problem because the concept can be applied in solving other problems as well. So what is the idea? That for a homogeneous system of equation which looks like Ax is equal to 0 to have a non-trivial solution. What is the requirement? Requirement is that determinant of A should be equal to 0. Determinant of the coefficient matrix should be equal to 0. So what is the determinant of the coefficient matrix here? I hope you know how to write the matrix representation. Matrix representation will look like 1 minus k, 1, k, 3 minus k, 3, 1 and minus 1, and this is the vector that is x, y, z, and the right hand side is equal to 0. So this matrix is the matrix A. This is the vector x, x, y, z is the vector x, and the right hand side is equal to 0. So what is the determinant value of this? 1 minus k, 1, k, 3 and minus k, 3, 1 and minus 1. If I calculate its determinant value, how will I calculate it? So let us expand it about the first row. So 1 and 3 into minus 1 is equal to minus 3, and minus k, so it will become plus k. This minus k, so it is minus plus k, and k into minus 1, that is minus k, and 3 into minus k is minus 3k, so it will become plus 3k. Okay, and then we have a 1 here, so I will write plus 1, and k into 1 is k, and minus 3 into 3 is equal to 9. I hope you got it. K into 1 and 3 into 3. So what we are getting? We are getting minus 3 plus k, and here we have 2k, so 2k into k is 2k square, and we are getting k minus 9 from the last term. So basically what we are getting, 2k square and k, so that will give me 2k, and minus 3 and minus 9, so that will give me minus 12 is equal to 0. So proceeding further, I can take 2 common from this, so I will get k square plus k minus 6 is equal to 0. Now I have to factorize this. So how to factorize? I will write k square plus 3k minus 2k minus 6 is equal to 0. Now I can take k common, so I will get k plus 3, and I can take minus 2 common, so I will get k plus 3 is equal to 0. So in the end, let me change the color so that it is not confusing. So here I am writing because of, or I can continue this small space here. So k plus 3 and into k minus 2 is equal to 0. So this gives me what? This gives me k is equal to minus 3 and 2. So we are getting two values of k, but which value of k is matching here? So the correct value of k that is matching is 2. So the correct answer in this case will be A. Because minus 3 is not present, so I have to select the answer as 2. For 2, it will be having a non-trivial solution. So I hope you understood the concept. Okay. So let us move to the next question. So if you look at this question, that if A and B are symmetric matrix, then which of the following is not true? So the first question is A plus B is a symmetric matrix. So we know that if we have to prove that A plus B is a symmetric matrix, I can take the transpose of A plus B, and using the property of transpose I can write A transpose plus B transpose, and since A and B are symmetric, so A transpose is equal to A and B transpose is equal to B. I hope you understand that a matrix is said to be symmetric if A transpose is equal to A. So that is the definition for the matrix to be symmetric. Similarly, if I take the matrix AB plus BA, so AB plus BA transpose will be what? What is the property of transpose? The property of transpose is that it is AB transpose plus BA transpose. Okay, and AB transpose gives me B transpose A transpose, and BA transpose gives me A transpose B transpose, and B transpose is B because B is a symmetric matrix, and A transpose is A, and here A transpose is A and B transpose is B. So this is nothing but AB plus BA, right? Because matrix addition is commutative. So AB plus BA transpose is equal to AB plus BA, means this is also a symmetric matrix. What about this one, AB minus BA transpose? So if I have to use the property of transpose, I will write it AB transpose and minus BA transpose, and this is nothing but using the property of transpose, it is B transpose into A transpose, and here I will write minus A transpose into B transpose. So B transpose is B, A transpose is A, minus A transpose is A, B transpose is B. So here it is AB minus BA transpose. If you look at this, I have to take minus common to write it AB minus BA. Yes or no? So this is a symmetric matrix? No, this is not a symmetric matrix. This is a skew symmetric matrix. Because what is the definition for a matrix to be skew symmetric? The definition is that A transpose should be equal to minus A. And here we note that if I am taking the transpose of this, we are getting minus of this thing. So that is why it is a skew symmetric matrix. So the question was that which of the following is not true. So this is a symmetric matrix is not true because this is a skew symmetric matrix. I have given you the detail because it will help you in solving other problems as well. Otherwise, it is very obvious that this is a skew symmetric matrix. Even though we have got the answer, I want to show you that A into A transpose and A transpose into A are also symmetric matrix, because if you take A into A transpose transpose, it will give me what? It will give me A transpose transpose into A transpose. And A transpose transpose is equal to A into A transpose. So you noted that A into A transpose transpose is equal to the same matrix, and similarly this is also symmetric. So the correct answer is this. I hope up to this there is no doubt. So let us solve this problem. This is a very simple problem. First of all, I hope you remember the or you understand the meaning of the term trace of A. So trace of a matrix A is nothing but sum of its diagonal elements. Sum of its diagonal elements. Okay, so here if you note it, they are asking me to find the trace of 2a plus 3b. So first of all, what is 2a? So 2a will be, it is not needed to multiply, but just because to explain it to you in a better way, I am doing it. So 2a is 2, 2 into 2 is 4, 4, 2, 2, and 2 and 2 into 2 4 and 2 into 3 6, and then 2 and 6 and 2. Because our concern is just the diagonal element, so I can look at this 2 into 2 4 plus 2 and 4 plus 4 plus 2. But for your understanding I am doing. What is 3b? 3b is equal to 3 3 3 3 into 1 3, 3 into 2 6, 3 into 1 3, 3 3 6. Right. So what is 2a plus 3b? So 2a plus 3b, and they're asking me the trace of 2a plus 3b. So I'm going to write directly now because it will take time unnecessarily. So trace of this means sum of this plus sum of this, because if I add the diagonal element, what will be the first diagonal element? 4 plus here, 4 here and 3 here. So that will be 4 plus 3. That will be the first diagonal element. Plus what will be the second diagonal element? 4 and 6 here. So I will get 4 plus 6. What will be the third diagonal element? That is 2 and plus 6. So what we are getting in the end? 4 plus 3 is 7, and 4 plus 6 10, and 10 plus this is how much? 8. So we are getting 18 plus 7 25. So which option will be correct? 25 is nothing but 5 square. So the option C will be correct. I hope up to this there is no doubt. Let us move to the next question. And this is an interesting problem, right? This is a like very interesting problem. So look at this very carefully. So what they are asking, that A is a non-singular matrix. First of all, I hope you know what is a non-singular matrix. A matrix is said to be non-singular if determinant of A is not equal to 0. So if determinant of A is not equal to 0, the matrix is said to be non-singular, right? And what is the property of a non-singular matrix? The property is that if determinant of A is not equal to 0, that A inverse exists. If it is equal to 0, when determinant of A is equal to 0, it is said to be a singular matrix. This is also a question which may be asked. So it is a singular matrix, right? So you have, when they ask that find out which of the matrix is a singular matrix, means you have to find that matrix for which determinant of A is equal to 0. Okay. So next what we have to do is to prove or find out the value of A inverse. So see, this problem requires a very smart approach, and what we are going to do, we are going to write the given expression, that is I plus A, where I is the identity matrix, A square up to A to the power n is equal to the null matrix. And since A inverse exists, we can multiply A inverse in both sides of it. So here we multiplied A inverse in the left side, in the right side. So if I multiply A inverse in the left side, we are getting this expression A to the power n. So what will happen? And look at this very carefully. A inverse into identity matrix, I will get A inverse. A inverse into A, I will get identity matrix. A inverse into A square, I will get matrix A. Here there will be A cube, so A cube into A inverse, I will get A square, and so on. The last term here is A to the power n, so I will get A to the power n minus 1 if I multiply it by A inverse. And A inverse multiplied into a null matrix will give me a null matrix 0, right? Now one thing I hope you all noted, that this expression can be written as A inverse plus I plus A square up to A to the power n minus 1, and in the left hand side we are adding A to the power n. So since we are adding A to the power n, one extra term in the left hand side, we need to add that term in the right hand side as well. So null matrix plus A to the power n. Now at this stage, you look at the expression which is appearing here in the bracket, and this is nothing but equal to a null matrix. So I get A inverse plus null matrix is equal to null matrix plus an, so we get an, and this implies that A inverse is equal to A to the power n. So the correct answer will be A. The A inverse value will be A to the power n. So this is a good question. I hope you understood this. Okay. Now look at this particular problem, and this is a very direct problem, definition based problem. They are asking me to find the rank of a matrix, and here the matrix given is 1 1 1 3 3 3 7 7 7. So did you notice one important thing, that actually the first row here is 1 1 1, and if you look at the third row, this is nothing but 3 times the first row, and the second row, 3 times the first row, and third row here is 7 times the first row. I repeat my point. First row is, I call it R1, second row is 3 times R1, and third row is 7 times R1. So there is just one row which is independent, so the rank of the matrix will be 1. Now if you have not understood through this approach, you can also consider to reduce this matrix into row reduced echelon form. For that you have to write R2 goes to R2 minus 3 times R1, and R7 goes to R7 minus 7 times R1. So I hope you will get here zeros in the second row and zeros in the third row. So there is just one non-zero row, so its rank is equal to 1. So both way means this was not needed. It was very much obvious that here the second and third row is just a multiple of the first row, so only one row is independent, so that is why its rank is equal to 1. Now if you look at this problem, this is a definition based problem. A rank of a singular matrix of order 4. So the matrix A is of order 4. Suppose I say that there is a matrix A and its order is 4, but it is a singular matrix, so it means its determinant is equal to 0, right? Now I hope you know the definition of the rank. The definition of the rank tells you, and if let me repeat it for your convenience, that suppose I say A is a matrix and its determinant is equal to 0, it means it is a singular matrix. Now what is the rank? Rank is the size of or order of size of highest order non-zero minor. It means what? that if you have a matrix, suppose for this problem the matrix is of order 4. So if matrix is of order 4, suppose it is like having A1, A2, A3, A4. I'm explaining it because it may be useful for other questions also. B3, B4, C1, C2, C3, C4, and D1, D2, D3, D4. Right. Now you can see that how do you define the minor of a matrix. So if I have to write one of the minor of the matrix, I can remove suppose the first row and I remove the first column. So what I will get a corresponding submatrix, and that submatrix will have a determinant whose value will look like B2, B3, B4, C2, C3, C4, D2, D3, D4. So this is known as a minor. So there are many such minors available. Actually, if I ask you that how many minors are available, so the total number of minors available are of size 3 actually will be you can leave any of the row in 4 way and any of the column in 4 way. So there will be 16 such minors possible. Yes or no? Now it is given that the matrix is of order 4, so determinant of A is equal to 0, so its rank certainly is not equal to 4. If we have a matrix of order 4, let me explain to you what are the possible rank. The possible rank is 0, 1, 2, 3, 4. 0 will be the rank when it is the null matrix, means every element is 0. And other possible ranks are 1, 2, 3 and 4. But it is given that it is a singular matrix, so the rank can't be 4 because the matrix determinant value is equal to 0. Now if I take any minor of size 3 cross 3 and if its determinant is not equal to 0, then its rank will become 3. So the answer is that what is the rank of a singular matrix of order 4 can be at most 3. See, I am not saying here that rank can't be 2, rank can't be 1, but in the question they are asking that what is the rank of what is the at most rank, the maximum rank it can have is equal to 3. Okay, now let us go to the next problem, and this is also a very simple memory based problem, that if we have a matrix whose size is 12 cross 20, then which of the possible is not a possible value of the rank, which of the following, rather it should be not be possible, which of the following, there is a misprint here, which of the following is not a possible value of the rank. So if I have a matrix A, then rank of A is less than or equal to the minimum of m and n. If we have a matrix of size m cross n, right? This is something that you have to remember as a concept, that rank of a matrix is less than or equal to the minimum of m and n. It means what? That in this case, if I talk about what will be the rank of A, so this will be less than or equal to the minimum of m is 12 and n is 30. So minimum of 12, not 30, sorry, 20. So 12 and 20. Now the rank of A will be what? Rank of A will be less than or equal to, what is the minimum of 12 and 20? So the minimum value of 12 and 20 is 12, right? So the maximum rank it can have is 12. So rank can be 12, rank can be 10, rank can be 0 if it is a null matrix. So rank can't be 13. Yes, so they are asking which of the following is not a possible rank. So correct answer will be 13 here. So this is the correct answer, right? I hope you will remember this concept. Now let us see this problem. For what value of k the set of vectors this and this is linearly dependent? So in this kind of problem, what we have to do, for this set of vector to be linearly dependent, I will calculate their corresponding determinant value. So to calculate the determinant, I am going to place these vectors as the row. So I am writing k, 0, k, 0, k, and when the determinant is equal to 0, it is dependent. I hope you know the concept. When you are 0, you are dependent. When you are non-zero means you are a hero, then you are independent, right? Heroes are independent, zeros are dependent. So for it to be linearly dependent, it should be equal to 0. Now you need to evaluate the determinant, and to evaluate the determinant I will expand it about the first column because we have a 0 here. So how to expand? K, this row is gone, this column is gone. K into K is K square minus K into 0 is equal to 0. Minus 0, so there is no need to write, and plus K. So this K, so this row is gone, this column is gone. K into K minus K into K. So I get K square minus K square, that is equal to 0. So what we basically get, this term is also 0. So we get K cube is equal to 0. So when K cube will be equal to 0? When K is equal to 0. So the answer is, correct answer is this. Linearly dependent means its determinant value should be equal to 0. Now if you look at this particular problem, this is an interesting problem, that if A is a matrix and its characteristic equation is this, then what is the values of A and B? So I hope you know that if we have a 2 cross 2 matrix, its characteristic equation is written as lambda square minus trace of the matrix, suppose the matrix I am calling A, so trace of the matrix A times lambda plus determinant of the matrix A, that is equal to 0. So if I have to write the characteristic equation of this matrix, what is the trace of this matrix? Trace of this matrix is 3 plus 5 is equal to 8. And what is the determinant of this matrix A? Determinant is 3 into 5 is equal to 15 minus 2 into 4. So 2 into 4 is equal to 8. So that is equal to 7. So its characteristic equation will be lambda square minus 8 lambda plus determinant is equal to 7. And we have to compare it with this now. So if I compare lambda square, in place of A I will get 8 and in place of B I will get 7. So which option will be correct? A is equal to 8 and B is equal to 7. So this option will be correct. I hope you will remember this, that how to write the characteristic equation of a 2 cross 2 matrix. Let's move to the next problem. Now this is a simple problem, that if A is equal to this and B is equal to this, and it is given that A square is equal to B, then what is the value of alpha? So what is A square? A square is alpha 0 1 1. This is A. So to find A square I need to multiply this alpha 0 1 1. So if I multiply, what I will get? Alpha into alpha, alpha square plus 0 into 1 is 0. So I will write 0. 1 into alpha is alpha, right? And 1 into 1 is plus 1. Then 0 into alpha, 0 plus 1 into 0, 0 plus 1 into 0, 0 plus 1 into 1, 1. So here we got alpha square, alpha plus 1, 0 and 1. And this is equal to, this is given to be equal to, it is given that A square is equal to B. So alpha square 0, alpha plus 1, 1, and this is equal to 1, 0, 5, 1. So the second column is same, 0, 1, 0, 1. So it means what? That alpha square should be equal to 1 and alpha plus 1 should be equal to 5. So alpha square is equal to 1 will give me alpha plus minus 1. And this will give me alpha is equal to 4. So did you note one thing? That here no value of alpha will satisfy this equation, because this is saying that alpha can be 1 or minus 1, but this requirement is saying alpha should be equal to 4. So the correct option will be none of this, right? I hope you got it. So now let us solve this problem quickly. Let A be a matrix, then what are the values, what are the eigenvalues of A to the power 3? So this is a memory based question, and I would suggest you to be clear about the properties of eigenvalue and eigenvector, because lot of questions are asked related to that. So here I am going to discuss two properties through this problem. So the first property is that if you look at this matrix, this is a lower triangular matrix. What kind of matrix is this? This matrix is a lower triangular matrix, and I hope you understand why it is a lower triangular matrix, because everything above the main diagonal is 0. So we have just a lower triangle kind of thing, right? If everything below the main diagonal is 0, then we say that it is an upper triangular matrix. But here everything below, above the main diagonal. I hope I have not made any wrong comment. Let me repeat. I am saying everything above the main diagonal is 0. So you see 0, 0, 0. So this is a lower triangular matrix. So for a lower triangular matrix, if I have to find the eigenvalues are nothing but the diagonal element. So the eigenvalues for this matrix will be nothing but 1, 3 and 7. This is the first property that we have to use. What is the second property? That if I have the eigenvalue, if I have the matrix A, and suppose whose eigenvalues are lambda 1, lambda 2 up to lambda n, suppose this is an n cross n matrix, then eigenvalues of A to the power m will be lambda 1 to the power m, lambda 2 to the power m, lambda n to the power m. So here they are asking me the eigenvalues of A to the power 3. So what will be the eigenvalue of A to the power 3? It will be 1 to the power 3, 3 to the power 3, 7 to the power 3. So that will be basically what? 1, 3 to the power 3 is 27 and 7 to the power 3 is 343. So the correct answer is A. Good question. It is usually asked in the examination. Now the next problem is again memory based, and which I already have discussed in this video itself, that find the product of eigenvalues of the matrix. So the product of eigenvalues is equal to the determinant of the matrix. This is a result which I think you should know. So the determinant of A is equal to the product of eigenvalues, right? So I need to calculate the determinant of this matrix. So determinant of A, 1, 2, 3, 0, 5, 8, 3, 2, 1. And if I expand it about the first column, 1, 2 into, 5 into 1 is 5, minus 2 into 8 is 16. Minus 0, so no need to write, and then plus 3, and 2 into 8 is 16, minus 3 into 5 is 15. So what we get? We get minus 11 from here, and 3 into 1. So minus 11 plus 3 is equal to minus 8. So do we have minus 8? Yes, the correct option is minus 8. So this is a important result, that determinant of A is the product of eigenvalues. Another property is that sum of eigenvalues is equal to the trace of the matrix, which you need to know. Now here this problem is that they have given a matrix and one of its eigenvalues is given. I don't have to calculate the eigenvalues. One of its eigenvalue is already given. Then what is the corresponding eigenvector? So you know how to calculate the eigenvector of a matrix. It is given, it is calculated by solving this equation, A minus lambda I x is equal to 0. Okay. So it means what here? It means that the lambda value that is already given in the problem is equal to 1. So I need to subtract lambda from the main diagonal. So if I subtract 1 minus 1, because I have to subtract 1 here, so 1 minus 1 will be 0, then 2, then 3, then 3, 0, 0, and then minus 2, 0 and 0, and the eigenvector that I need to solve it for is xyz, and the right hand side is equal to 0. So basically this is a homogeneous system of equation, and I am taking the first two equations. So suppose I take here the first equation. So first equation will be 0x, so no need to write, 2y plus 3z is equal to 0. And if you look at the second, it will give me 3x is equal to 0, right? Now eigenvectors are a non-zero vector, so we know that it will have a non-zero solution, right? In case if you are not clear about how to calculate eigenvector, then first you should be clear about that. But anyway, I have taken the first equation, like 2y plus 3z is equal to 0, and then 3x is equal to 0. So this equation gives me x is equal to 0. Now this is very important point I am repeating, that eigenvectors are non-zero vector. Eigenvector is a non-zero vector. Non-zero vector. So ladies and gentlemen, if I have to solve this, x I already have got 0. So if I have to solve this, I can take some value of z. So sometimes a student do the mistake that they take z is equal to 0, and then in that case they get y also equal to 0. So x is already 0, so you get a 0 vector, which is not correct. So what we do, we take z is equal to 1. So if I take z is equal to 1 here, this equation gives me 2y is equal to 3. In the right hand side will become minus 3. So I get y is equal to minus 3 by 2. So the eigenvector that we are getting is 0, y is minus 3 by 2, and z is equal to 1. But if you look at the option, none of the options are similar to this. But one important point you need to know, that any multiple of this will also be an eigenvector. So if you allow me to multiply this by minus 2 to make it similar to one of the options, it will become 0. Minus 2 into minus 3 by 2 is 3, and minus 2 into 1 is minus 2. So 0, 3 and minus 2. So A will be correct. So what is the correct option? Option A. Right? Now this is again a memory based question, that find the eigenvalues of A inverse. And you just have seen earlier I was talking about a lower triangular matrix. Now this is an upper triangular matrix, because everything below the main diagonal is equal to 0. So if I ask you what are the eigenvalues of this, the eigenvalues of this is 2, 1, 4, just the diagonal element. And another important property of eigenvalue is that if we have a matrix A and its eigenvalues are given by lambda 1, lambda 2, lambda 3 up to lambda n, suppose I'm talking about a general matrix of order n, then A inverse will have its eigenvalues given by 1 by lambda 1, 1 by lambda 2, up to 1 by lambda n. So what will be the eigenvalues of this matrix? So it will be 1 by 2, it will be 1 by 1, it will be 1 by 4. So basically I will get 1, 1 by 2 and 1 by 4, which is nothing but this option. So you notice that knowing the properties of eigenvalue and eigenvector is important. I will try to create a video separately for all these topics. Right. Now let us move to this question, and this is also an important question based on Cayley-Hamilton theorem. So it is given that if a square matrix A has its characteristic polynomial, that is lambda square minus 2 lambda plus 1 is equal to 0, then what is the inverse of the matrix? So the first thing is that using Cayley-Hamilton theorem. What is Cayley-Hamilton theorem? Cayley-Hamilton theorem tells you that every square matrix satisfies its characteristic equation. So if I use that, means in place of lambda I put A, the matrix A, so A square minus 2A, and in place of 1 we need to put identity matrix, because we have to make it in the form of a matrix equation. So that is equal to 0. Now this is because of the Cayley-Hamilton theorem. But they are asking me to find the inverse. So whenever we have to find the inverse using a Cayley-Hamilton theorem, once we apply it, we multiply both sides of the equation by A inverse. So we multiply it by A inverse. So A inverse minus 2A plus I is equal to A inverse into null matrix. So what we get? We get A minus 2I plus A inverse is equal to 0, null matrix. I hope you got it. A inverse into A square is A. A inverse into A is identity matrix. A inverse into identity matrix is A inverse. Now what is A inverse? A inverse is minus A plus 2I. I am taking this term minus A and 2I in the right hand side. So I am getting minus A plus 2I. So which option is correct? The option this is correct. Okay. So interesting question. Now let us solve few more problem quickly. Now this is also based on the properties of eigenvalue, that if lambda 1, lambda 2 and lambda 3 are 3 eigenvalues of this matrix, then 2 times lambda 1 plus lambda 2 plus lambda 3. So you know that there is a property that trace of A matrix is equal to the sum of eigenvalues. Sum of eigenvalues. So it means if I ask you what is the sum of eigenvalues, that is lambda 1 plus lambda 2 plus lambda 3, that is equal to the trace of the matrix. And trace of a matrix means sum of its diagonal element, like 1 plus 5 plus 1. So how much is that? That is equal to 7. But they are asking 2 times lambda 1 plus lambda 2 plus lambda 3. So this is equal to 2 into 7. So means it is equal to 14. So the correct answer is 14. Okay. Finally, this question is also based on the Cayley-Hamilton theorem, and first of all I need to write the characteristic equation. Do you remember in one of the previous problem we have discussed that for a 2 cross 2 matrix the characteristic equation is given by lambda square minus trace of the matrix time lambda plus determinant of the matrix is equal to the null matrix. So here it is lambda square. What is the trace of the matrix here? 4 and minus 4, so it will become 0. So I will get 0 lambda. And what is the determinant of it? So determinant is 4 into minus 4, that is minus 16, and minus 9 into 2 is minus 18, means here I have to write minus minus plus 18 is equal to 0, null matrix. No, I mean here I am writing in terms of lambda, so it is 0. So I am getting lambda square and plus 2 is equal to 0. This is my characteristic equation. Point number 1. Point number 2, if I use Cayley-Hamilton theorem, let me continue in this side. So Cayley-Hamilton theorem will tell me what? That a square and plus 2i will be equal to the null matrix. Every square matrix satisfies its characteristic equation. So a square is equal to minus 2i. But they are asking me to find the a to the power 8 power. So a to the power 8 power is what? Basically it is a square into a square. So here you see that we have to take minus 2i into minus 2i into minus 2i into minus 2i. So minus 2 multiplied 4 times will give me 16, and this is an identity matrix. So if you multiply identity matrix 4 times, you will get the identity matrix. So the correct answer is 16i, which is the first option. Okay. So in this video we have solved some multiple choice questions related to matrix. In case if you are able to watch the video till the very end, I would certainly suggest you to like the video and share with all your friends who are expected to write their exams where this may be a part of the syllabus. If you want more videos, I would expect you to actually motivate me, and to motivate me you have to subscribe the channel. Another important thing is that while solving all the problem, I have made sure that I also discussed the related concept to it. So in the coming videos also we are going to follow the same. While solving it, I will be discussing the related concept also. And in case if you find that any of the concept you could not understand, you should certainly put that in the comment section. So thanks for watching. Have a great day.